thing it will happen is this is at point A. A part of wire, what happen, will be used for connection. I'll put not something, whatever you do it. A part of wire I'll use for connection. So small part of wire, what happen, will come here, no? So in our measurements, what we do, we do measure from here. So let's continue like this. So this is the balancing length, and somewhere the jockey will be here. I'll continue this. It will be easy for you. This is at A and B, no? So when you say the length L, so from where you'll be measuring? You'll be measuring from here, no? So this part of the wire, what happened, will be missing. So which part of the wire? So you can see that this one. I'll just indicate by some green color. This part, what happened, though it's a length of the wire only, but it is used for connection. So when you say L, actually what happened, you have to measure this green color also. So some part of this, I'll call this as like a lambda, the length of this, let it be alpha. Here some length, let it be beta. Able to get this? So small length, I'll call this as alpha. The small length here, let it be beta. What is actually balancing length? It should be alpha plus L. So what are alpha, beta? Alpha and beta are small length of meter bridge wire used for connection and cannot be measured. It's over, you can't measure that. I'm using specifically the word cannot be measured, because that particular wire is used for to make connections or to put a knot. Can you measure the length of the knot? Not possible. So when you say balancing length is alpha, it's L, it's wrong. So what should be the balancing length? Alpha plus L. Okay, getting the idea now? So now this has to be taken care. Now how to, these are called like end corrections. So what we do is, these are called as end corrections. So how to take care this also. Even this also matters here. Alpha, beta are not negligible. So I'm making right it. Alpha and beta are not negligible and they cannot be measured. So how to obtain that? So what we do is, I'll go for end correction. So first what I do is like in the same meter bridge experiment, there's a wire. This is there, not there in NCERT book, not there in S.C. Verma, nor there in any of the competitive book, and it's there in lab manual, and they've asked it. So you have to be extra careful about the some things which are there, no? So they've asked in advance directly. So I'll first connect some known resistance R1, R2 in the gap here. In the books also not mention things very clearly what these are, and this is A, this beta, and that green color I'll indicate a part of wire which is used for to make connection and which cannot be measured. Got it? So this is the okay. Now let's derive a mathematical expression. So I'll see that current through galvanometer is 0 and the balancing length I'll obtain L1. Okay, now this alpha beta, let me write it here, alpha, and this is beta. The bridge is balanced, current through galvanometer is 0. So ratio of the arms, so they should be alpha and beta's length of the segments are not resistance. Alpha beta small length of meter bridge wire used for connection and cannot be measured. Try to see this. So when bridge is balanced, what you write, R1 plus R2 is equal to P by Q. So what is the resistance of this part? Lambda into L1 plus alpha. What is the resistance of the other wire? Lambda into 100 minus L1 plus beta, it should be. Or shall I write 100 minus L1 plus beta? Uh, 100 minus, shall I go for bracket, or shall I write only 100 minus L1 plus beta?
No bracket.
No bracket, it should not be there, no? So 100 minus L1 is the length, no? The remaining thing that should be added here. So this is what I'll get one thing. So R1 by R2. R1, R2 are known. I know this value. Known this one. So this will become L1 plus alpha, 100 minus L1 plus beta. Keep it here. So now I'll interchange these resistances. R2. These are the known values. I'll interchange that known values, R2, R1. I'll measure the balancing length. So let it be L2. Again, the current through galvanometer, I'll make it 0. Then in this case, what you can write? R2 by R1 should be equal to lambda into L2 plus alpha by lambda into 100 minus L2 plus beta. So dividing this, R2 by R1. So R1, R2 are known for us. So solving this, we'll get expression for alpha and beta. Let me write directly. So R2 L1 minus R1 L2 by R1 I2, and beta is equal to R1 L1 . Now you have to solve this actually. These are end corrections. So what are alpha and beta? Alpha and beta are, they are not resistance. The length of the segments which are used for to think that one. So do remember in exams, I think you can't derive. So better to remember this formula.